Welcome back. Today we're going to be talking about the time-weighted rate of return. And so the time-weighted rate of return is a rate of return that is used to measure growth in an account or a fund for a 1-year period of time by compounding returns over successive parts of the year. And so for example, if you take a look at this timeline here, where we are looking at a time period of 1 year, let's say that we had a fund or an account that had a 5% interest rate for the first 6 months, and then a 3% interest rate for the next 3 months, and then a 2% interest rate for the last 3 months. And so, what we would do to calculate the time-weighted rate of return for a scenario like this is to compound the returns for the fund for each of these parts of the year. And so using these 3 interest rates, let's say that the account had a $1 investment, that $1 would be multiplied by 1.05, which is 1 plus this interest rate, times 1.03, which is 1 plus this interest rate, times 1.02, which is 1 plus this interest rate, and that would be equal to the growth of that $1 investment, right? And so if we were to multiply all these values together, that $1 would increase to be $1 with the following decimal values of 1031. And so what this tells us is that our investment of $1 increased by 10.31%, right? Before we had $1, but now we have 1.1031, and so our investment grew by that 10.31%, and this right here would be our time-weighted rate of return, right? This measures the growth of an investment in an account for a 1-year period by compounding the returns over successive parts of the year. And so we label the time-weighted rate of return as capital T, capital R, and so the time-weighted rate of return would be equal to that 10.31%, like we said. But notice that the amount of time that each interest rate was active was not taken into account to calculate this rate of return, right? We compounded the rates over successive parts of the year and ignored the fraction of the year, or the amount of months, that each rate was active for. And so that's the idea of the time-weighted rate of return, at least in a general sense, but how would we calculate it if we were given the balance of a fund at the beginning and the end of the year, as well as some cash flows that are taking place within that year? Well, if we clean up our work here, let's say that this timeline still represents a period of 1 year, where the first endpoint would be January 1st of that year, and the other endpoint would be December 31st of that year, right? And then let's represent the initial balance of this fund with the letter A, right? That is how much is in this fund or in this account at the beginning of the year. And then in a similar way, we will represent the amount in the fund at the end of the year with the letter B. And then for any moment in time throughout this year, between these two endpoints where we might want to report the balance of the fund, we will represent that balance with F and then a subscript to represent the order in which those balances are reported, right? So the first one would be F sub 1, and that would be the first time that we are reporting a balance between the endpoints. And then our second balance would be F sub 2, and that would be a point in time further along, but still within the year and before the endpoint. And you can continue to have moments in time where you would report the balance of the fund. And then, of course, don't forget any cash flows that might be taking place for this account or for this fund throughout the year. And so we will represent those with plus or minus C sub 1 for the first cash flow, and then plus or minus C sub 2 for the second cash flow. And then just like the balances, we could have as many of those as we wanted to as well. And that plus or minus is just to represent that these cash flows could be deposits or withdrawals, where the deposits would be represented with the plus sign and the withdrawals would be represented with the negative sign. Okay, and so then it's also important to know that these values of F, or these balances of the fund at specific moments in time, these do not include these cash flows, right? These are the balances of the fund at these particular moments in time before any deposit or withdrawal is made, right? So these are just the balance of the fund before any cash flows take place. All right, so that's important to remember, especially when we get into the calculations for the time-weighted rate of return. Okay, and so given all this information, we could calculate the time-weighted rate of return with the following formula. The time-weighted rate of return is equal to the first reported balance after the initial balance, F sub 1, divided by the initial balance of the account. And that's multiplied by the next reported balance, F sub 2, divided by the previous reported balance, F sub 1, plus any cash flows. And then that would be multiplied by the next reported amount for the balance, if we had one, divided by the previous reported amount, plus any cash flows for that moment in time. And then we would multiply all the way up until we get to our last reported balance for the account throughout that year, and divide that by the previous balance plus any previous cash flows at that same moment in time. And then we would multiply that by the end balance of the account divided by the last reported balance of the account plus any cash flows at that moment in time. And then you would subtract 1. All right, so that looks like a very complex formula, but it's actually not as complicated as it looks. This is very similar to that calculation we did just a little bit ago, where we multiplied 1.05 by 1.03 by 1.02, except it is written out more explicitly in terms of the actual values for your account. Right, we are still compounding the returns over successive parts of the year with this calculation. This first fraction right here represents the growth of the fund from the initial balance to the first moment in time where the balance of the fund is reported, right? We have F sub 1 divided by A. This fraction represents the growth of the account for that period of time, and then this fraction would represent the growth of this account for this period of time. And then if we had more moments in time where the balance was reported, such as F sub 3, this would represent that period of time, and then that would continue on until this final fraction where this represents the growth for the period of time between the last moment in time where the balance was reported and the end of the year on December 31st. And then subtracting 1 allows us to get that specific time-weighted rate of return that would measure the growth of our account for that entire year by compounding the returns over successive parts of the year. Okay, so that's what this formula is doing to calculate the time-weighted rate of return. If it still seems pretty complicated, don't worry. It is a lot simpler to use than it seems once you see it used in an example problem. And so let's take a look at an example next. Okay, so here's our example problem. We have that an investment fund has an initial balance of $100,000 to start the year. On April 1st, the fund increased to $112,000 and a deposit of $30,000 was made. On October 1st, the balance was $125,000 and a withdrawal of $42,000 was made. And then at the end of the year, the balance of the fund was $100,000. Determine the time-weighted rate of return. Okay, and so what you want to do here, every time that you want to calculate the time-weighted rate of return, is to draw a timeline for your scenario and label the timeline with all the different balances, all the different cash flows, and their respective dates. And so in this case, how many dates do we need to make a note of? Well, we know that we have an initial balance, so that's going to be January 1st. That's one date. Then we have a reported balance for the fund on April 1st, so that's our second date. And then we have another reported balance on October 1st, and so that's our third date. And then we have a balance of the fund at the end of the year, and so that's our fourth date. And so we're going to have 4 moments in time throughout this 1-year period that we need to make a note of on our timeline. And so let's draw our timeline. We'll have 2 endpoints and then 2 points in between. And so our first moment of time is January 1st. Our second moment in time is April 1st. Our third moment in time is October 1st. And our last moment in time is December 31st. Okay? And so we know that the initial balance on January 1st is $100,000. And so we will have $100,000 right there. And then on April 1st, the fund increased to a balance of $112,000. And so we will have $112,000 right there. But then we're told that there is a deposit of $30,000 that is made on that same date of April 1st. And so below this balance, I'm going to write plus 30,000. And so that plus represents that this is a deposit made at this moment in time. That is not the balance of the account. This $112,000 is the balance of the account because it doesn't have a plus or minus in front of it, right? So try to keep track of that. That's at least how I like to do it. I like to write all the balances on the first row and then have a second row of any cash flows, but I also like to add either a plus or a minus in front of those cash flows to label them as either a deposit or a withdrawal. Okay? And then on October 1st, the balance was $125,000, and so we will have $125,000, and a withdrawal of $42,000 was made. And so below that, I will write minus $42,000 because that is a withdrawal, and so we are subtracting out that money. All right, and then we're told that at the end of the year, the balance of the fund was $100,000, and so we will have $100,000 at our last endpoint there. Okay, and so now we are ready to determine the time-weighted rate of return. Okay, and so if you wanted to, you could try to follow this formula very closely and try to label each of your values with the letters that are used in the formula. However, I'm going to show you a little bit of an easier way. It's a little more intuitive. We're still using the formula, but we're just going to be looking at the timeline instead. And it is a very easy process to repeat every single time to set up the equation for solving the time-weighted rate of return. And so here's what you do. The first thing that you want to do to set up the equation is look at your first reported balance of the account. Not the initial balance, the first reported balance of the account for that year. You're going to have that the time-weighted rate of return is equal to that balance of $112,000 divided by the initial balance, the previous balance, right? So we're going to write $100,000. And then we're going to multiply that by the next reported balance for the account, which is $125,000, right? We already worked with this reported balance, so now we're going to move on to this reported balance, and so we will have $125,000, and that will be divided by the previous balance plus any cash flows. And so $112,000 plus $30,000 will be $142,000. And then we will multiply that by the next reported balance, which happens to be the end balance. And so we will have $100,000 divided by the previous balance plus any cash flows. And so in this case, we have $125,000 minus $42,000, right? We would be adding a negative amount. And so that would be $83,000, right? 125 minus 42 is 83, so we have $83,000. Okay, and so then this would be the final part of our calculation before we subtract 1, because the numerator is our ending balance. And so we can just subtract 1, and this equation right here will calculate the time-weighted rate of return. Okay, and so just to review, here's what we did. We started with our first reported balance for the account that is not the initial balance, and we divided that by the initial balance. That was the first part. That takes care of this period of time for this account. Then we're going to work on the next period of time by taking the next reported balance of the account, $125,000, and dividing it by the previous balance plus any cash flows, right? That's where this $142,000 came from. And so this fraction takes care of this part of the year for the account. And then this last fraction has the next reported balance of the account, which happens to be the ending balance divided by the previous balance plus any cash flows. And so that's where this $83,000 comes from. And so this fraction takes care of this part of the year, which is the last part of the year. And so now we have 3 fractions that represent the 3 parts of this year. And so we are compounding the returns over these successive parts of the year. And so then we can subtract 1 to finish off this calculation. Okay? And so if you were to plug all of this into your calculator, you would multiply these fractions together and then subtract 1, you would find that the time-weighted rate of return is equal to 0.1878, which would be the same as 18.78%, right? That would be the time-weighted rate of return for this scenario. Okay, and so that's how you use this formula to calculate the time-weighted rate of return. It's actually not too complicated once you see how it's done with an example like this. All right, and so that's all I had for this lesson. If you want to see some more examples to get a better idea of how to use this formula, feel free to check out our examples video that I'll have linked at the end of this video as well as in the description below. If you have any questions, feel free to leave those in the comments, but if you don't have any questions, this is all I had for now. So I will see you next time.